Okay, hi guys. So today we are going to discuss what exactly is a time complexity and what is space complexity and what are their importance and where do we use time and space complexity and like how to calculate the time and space complexity whenever asked. Okay, even in the interviews or in the real life world. So we'll just look into that. So let me just talk about some of the terms that we are going to discuss today. Okay, some of the terms will be. Let me just write those terms. First term will be time complexity, obviously, because it is one of the important topic that we are having. First is the time complexity, and the second will be space complexity. Okay, and after time and space complexity, we are having some sub terms in the time complexity itself. So let's just understand firstly that what exactly is time complexity and what is its use. Okay, and then we are having the space complexity. So what exactly is the time complexity? Time complexity is the basic time. Okay, we can say the time. Okay, the magnitude of time in which a particular algorithm is getting completed. Okay, for example, if we are having an algorithm or if we are having a code that is taking let's say 15 seconds to run. Okay, to run completely, so it is having more time complexity. And if the same functionality is being achieved by some other code that is just completing that or it is just completing itself in 5 seconds and it is doing the same work, then that particular code will be preferred in the real world. Okay, and where exactly these terms are used, these terms are not used in small use cases. Okay, when we are having small input and when we are having small output, we do not use these particular two terms. Okay, that is the reason because that is the reason why you didn't heard of time complexity and space complexity while you were doing Java and while you were doing the initial years of your engineering. Okay, you do not hear about these terms because they actually get into use when we are having a very large input and we are having a very large output. So what exactly happened? Let's say we have just made a particular program. Okay, like till now, the programs that you have made, okay, they must be of at max 1000 lines, right? And it must be accepting some input. Let's just talk about a function that is taking inputs and it is giving output. So let's say at max you have made a function that is taking 1000 inputs and it is giving you some 2000 outputs, right? This is our basic function program that will just take in 1000 input. Okay, and it will just produce 2000 outputs. So this is a basic function. So what will happen if the particular time taken by this particular program is let's say 10 seconds. Okay, the time taken by this particular program is 10 seconds. Okay, and let's say this particular program is running in 10 seconds. Now what if there comes a situation that I'm saying that okay, now the particular whole world, okay, now the whole world is using our application and the same application will be receiving inputs from the complete whole world. So what will be the number of inputs? Let's say the number of inputs are now 10, and let's say firstly we were having three zeros and I will just increase the number of inputs. So this was three zeros, now I am increasing it to 4, 5, 6 and 7. Let's say we have just increased it to 1 crore. Okay, now if we are having 1 crore inputs, now you can just think that for 1000 inputs, if our program was taking 10 seconds, then for one input it is taking approximately 10 divided by 1000. Okay, so for one input it is taking 10 divided by 1000 number of inputs. Okay, for one input. So it is for one input it is taking 10 divided by 1000 seconds. Now for 1 crore inputs it will just take in multiplied by 10, sorry, multiplied by 1 crore. So it will be 1 divided by 100. If I will just cross cancel out the zeros here, so it will be 1 divided by 100 into 1 crores. So it will be at the last it will be 1 crore divided by 100. So it is just a basic simple mathematics. So if I will just decrease the two zeros, now we can just see that the time that this particular program is taking is 1 lakh seconds, right? So now we are having a program that is taking up 1 lakh seconds. So now this particular thing, Okay, you can just see that if we are writing the algorithm in the same particular manner, then that particular program is taking 1 lakh seconds for 1 crore inputs. Now, but if I just change the algorithm and I write it in such particular in a particular manner that for 1000 inputs it is only taking, let's say, 1 second. Okay, now this is the second example. For 1000 inputs it is taking 1 second. So for one input, it will take 1 divided by 1000. So it will be 1000 in 1 divided by 1000. And here what we will do, we will just divide it by 1000. So from 1 lakh, the number of time or the time that it is taking it is 10,000. So by just changing a particular algorithm, we just saved our 90,000 seconds. Okay, so that now the total time is only 10,000 seconds, and earlier it was 1 lakh seconds. So you can just see that when we are talking about the large number of input and large number of output, that generally these particular organizations such as Facebook, okay, Facebook Meta, and Instagram, Apple, and very big organizations, and there are plenty of organizations, like there are like thousands and millions of organizations that are having again millions of input. So if we are having that large number of input, then we need to understand, we need to reduce the time and space complexity, and even for the space as well. If 1000 inputs or the program taking 1000 inputs is taking 1 KB, or it is taking 1 GB of space, for example, it is a complete software, then for that it will just take a lot of space, and we can just like relate it with the time complexity itself. So time complexity is related to the time saved, space complexity is related to the space saved. And generally these kind of data structures that we are having, okay, generally these kind of data structures that we are having, just a second. Yeah. So what we are having the time complexity and the space complexity saved here. Like by just reducing the time for 1000 inputs, by just reducing it to 10 times, divide by 10, we were also having the total final time, that is always divided by 10. So yeah, we have just saved in 90,000 seconds, and you can just see that if we are talking about Facebook, Amazon, Flipkart, or even Netflix. For example, Netflix is handling requests, and let's say a lot of people are logging into their Netflix account. And if Netflix is taking, let's say, 10 seconds for each user, then it will be a lot of waiting time if we are having 1000 users queued up in the Netflix for logging in. Okay, so we have to just like think of a large number of input, and whenever we are having that large number of input, we are having time and space complexity. So this is the reason why we study data structures, to just understand that what are the types of basic data structures that we can just use to store our data. Okay, now again, let me just give an example. Let's say we are having elements as 10, 20, 30, 40, and 50. Okay, so there are plenty of ways to store these different data, and there are plenty of ways to find a particular element into this data. Let's say we are just storing it into the particular format of an array, and we want to search in, let's say, 30. Now to search 30 out of a particular array, what we will do? We will just iterate the array. Firstly, we will just check whether this first element is equal to 30. If it is not, we will go on to the second element, it is equal to 30 or not, and then the third element. Now let's say the element that we want to find is 50, for example. Okay, now this algorithm will work. Firstly, we will check in first element equal to 50, no. Second element equal to 50, no. Third element equal to 50, no. Fourth element equal to 50, no. And then the fifth element will be equal to 50, and then we will be having the answer. Now just check the number of steps that we did. We just ran our algorithm, or we just checked the basic if condition 5 times. Now just imagine if we are having the array, okay, or any particular value that is in crores or thousands or lakhs. Whether, let's say, we are having a dynamic array that is having the value up till 6,000, 5,000, right? Now to find a particular number into this particular array, it is really difficult if we just choose this particular method, because it will be taking a lot of time, and again the time and space complexity will increase. So that was a basic theory. Now just understand that if this particular values, if these particular values are stored in the form of a tree, let's say, so that is 10, then 20, then we are having 30, or let's just write it as, okay, that was fine, 10, 20, 30, 40 and 50, for example, right? Now, let's say we are just doing a normal iteration. Okay, I'm not just using any particular algorithm or anything. Let's just see we are doing a normal iteration. So what we will do, we just want to search into this particular tree. So firstly, I will go on to 10. I will see the 10 is not equal to 50. So we will just go on to the left child of this. Again, 20 is not equal to 50. Then we will go to the left child of this, for example. Now 40 is not equal to 50. Then we will go on to the right child. And here we just saw that after 4 steps, by just converting it into the tree, within 4 steps we were able to find that particular element that we wanted. Yeah, you could have also gone on to the 30. Okay, so that depends which a particular approach you are using, and it is all dependent. Like even in this particular case, if you are just searching from backside, then on the first step itself you would have got your 50 as the answer. So that depends what data structure you are using and in which particular manner you are just iterating over your particular data structure. Okay, so that was onto the tree. And now talking about the stack again. Now for the stack, what will happen? 10 will be at the bottom, then we will be having the 20 because uh, element added first will be in the bottom of the stack. Then we will be having 30, we will be having 40, and we will be having 50. Now the same 5 elements, and now if I want to search 50, it will be searched after first step, and if I want to search 10, it will be searched after the fifth step. Okay, so that depends situation to situation which particular data structure I want to use. Okay, and again, taking another example, if I will just create a particular graph here, that is 10 20, the graph is of my choice. Okay, so there is no particular hard and fast rule that how do you want to create a graph. Okay, so let's say I'm just creating a graph like this one. Okay, the elements are not in a particular order, but I am just creating this graph and I am just making the connectivity in this particular manner. Okay, so this is a particular graph that we are having. Okay, yeah, 20 and it will be just joined in the same manner. Okay, so we are having the elements in this particular manner. Now let's say we are starting any particular value, we are just starting from 10. Now starting from 10, I just want to search 50. Then how many steps will be there? I can just go on one step and then the second step. 50 will be uh, searched after 2 steps. Okay, and let's say we are now starting from 40, for example, then 50 will be searched on to the after one step itself. Okay, so that is the basic dependency upon the data structure, and we can see each data structure is unique and we are having different uh, use cases of each data structure. Okay, so moving further with this one, now let's just understand that what are the various terms in the time complexity itself. Space complexity is also important, but it is not used widely. Why? Let's just understand that firstly. Because space complexity, talking about space complexity, why are we not gonna study space complexity, or why somebody won't ask you about the space complexity? The reason is that space complexity is actually dependent upon the programming language. Okay, it is dependent upon the programming language because what will happen if you are working in Java and the same particular code for write or for adding two numbers, okay, will be having a different file size, and the same particular code for adding two numbers in Python will have a different file size. So that all depends upon the programming language to programming language. And generally, even if we are having a large code, even if we are having a code that is having 1000 lines, 2000 lines, even then the space complexity won't matter much. Okay, because it is just the code, it is just the text file in general, it is just the instructions file in general. So that is why the space complexity won't increase, and it is not really a factor for your interviews and at your college or graduation level. Okay, space complexity is generally considered when you are handling files, when you are mainly into the database. Okay, then this particular portion comes into play, the space complexity. But during simple data structures and algorithms, space complexity is not really considered. Okay, it is just that it should not be like you are just creating or you are just initializing variables without their use. What happens, let me just tell you. For example, we want to do sum of two numbers. Now we know that whenever we declare a particular variable, it will just take up the size of 4 bytes, right? Generally, an integer, it will take up the size of 4 bytes. Now, let's say we are writing a program to sum two numbers, and what if I'm just creating the variables in this particular manner? Int a is equal to this, int b is equal to 20, let's say int c is equal to 30, and what we are doing? We are just gonna add up these four numbers. Int d is equal to 50, 40, and int e is equal to 50. Let me just change the question. Sum of sum of 10, 20, 30, 40, and 50. So I'm just asking you that just write, give me the sum of this particular value. And let's say if you are doing you're writing your program in this particular manner, that is a plus b plus c plus d plus e. Okay, so this particular approach, what will it do? It will actually initialize six variables, that is a to e, five variables. So 5 fours are 20, and then some will also take up the 4 bytes. So 20 plus 4, 24 bytes. So this whole program is running and it is taking the space of 24 bytes in the memory. Now, let me just change the particular program, or let me just change the particular approach, and we will just do the sum here. And what will I do? Rather than instantiating these values, I will just write int sum, and I can just write it directly. Clear? Or I can just initialize sum is equal to 10, and then I can just give that uh, int sum is equal to 10 plus, or let's just do it directly itself. I can just write in the single statement here, that is 10 plus 20 plus 30 plus 40 plus 50. Now what's happening in general, we are only taking 4 bytes of space. Why? Because this 10, 20, 30, 40, 50 are not being sent into the memory. They are just being calculated, and we are directly just adding them up. Rather than creating five different memory pointers here, we are just directly doing the sum of these values. So these are some particular approaches that you should just follow. Clear? And generally space complexity doesn't matter much, because what will happen if you will just try to do this particular approach? Now let's say I am just saying that please change the second number to 200. So you will have to just make a change here, and maybe it is confusing if we are having a lot of numbers, that what is the second number, what is the fourth number. For example, I want to add 100 numbers, so I'll have to count, for example, what is the 57th number that I have written. But here I can just directly see that what is the 57th row, and I can directly change in the value. So that depends, that is a situational, but in general we avoid space complexity. Now talking about time complexity. So now we understand some terms according to the time complexity. Now what are these terms that we are having in the time complexity? Okay, in general the time complexity is having some particular terms that is known as worst case. Let me just write here, or let's just start from the best case time complexity. Best case, and then we are having the average case, then we are having the worst case. Okay, so what happens, let's say we are having the array. Okay, we are having a particular array that is 10, 20, again 30, 40, 50, 60, and I will just increase the size of the array 70, 80, 90, and 100. Okay, so let's say we are having these particular elements, and what is the number I want to search? I want to search for, let's say, 10. So it is possible that in my array the particular number that I want to search will come up at the first position. Now that will be the best case according to the time, that it will just take only one step, and it is the best case that can ever happen, and it is a lucky thing, okay, that you are just having the element in the starting itself. In the first step itself we are just having the element. Average case can be you are having the array, and inside it, let's say for example, the particular value that we want to find out, okay, the particular value that we want to find out is towards the center, for example. So this can be termed as the average case. It can be towards the center, it can be third last, it can be fourth last. And what will be the worst case? Worst case will be when your particular number that you want to find will be on the last value. Okay, it will be accessed at the end, it will take the maximum time. Now while you are writing a particular program, guys, what we never focus on the best case, because the best case will be obviously one. But What we want to prepare our program in such a manner, okay, that it takes what is the maximum time that this program will take. We just need to know that so that we can just handle the basic application more easily. Okay, for example, if you are making a calculator, okay, the best case can be the calculator is returning your answer in 0.00001 second. But you also need to be sure that there can be situations when your calculator is not performing well. So we should be having the last value, that whether the calculator is having the worst time case complexity or the worst time complexity of 5 seconds, 10 seconds, or maybe we should just be careful that it should not go up till 50 seconds, for example. That is why we just handle the worst case. Okay, so it is just like we are just talking about the best scenarios. We are saying, yeah, if it is best, then well and good. But what if we are not having the situations according to the expectations? Then what will happen? So that is why we just study the worst case time complexity, and this is the time complexity that will be asked you every time. So the worst case time complexity is generally denoted by omega. Okay, the term used for the worst case time complexity is the big O notation, sorry, not omega. That is the big O notation, and we write this big O notation as O and then the particular value here. Clear? It is generally the n value here. That is the number of steps or the number of time complexity. That is the big O notation, and it is the worst case. The average case time complexity is denoted, okay, it is denoted by the omega notation. Okay, now what is the omega notation? Let me just it is just like the horseshoe shoe. Okay, so what is the horseshoe? Let's just draw it. So it is somehow like this one. Okay, so that is the omega notation that we have for the average time cases, and then we are having the theta notation. So every time you will just have the interview or anything, he or she can ask you what is a theta notation, what is an omega notation. But whenever they will talk about that, what is the time complexity of this particular algorithm, it is obvious they are asking you about the worst time complexity, because this is the time complexity that we study and that we want to be in control. Okay, so theta is written in this particular manner. It is just like a zero that is having a particular horizontal line in between it. Clear? So that is theta notation. Now moving further, what is a basic worst case? Now talking about the worst case time complexities, we are going to study the worst case time complexities. That is the big O notation, and we are going to write it in the O and the N value. Now what can be inside the N value? For example, I am writing 0. I can just write here 0, 1. Okay, that is O actually. O of 2, O of 3, O of 4, and so on. Here we are having O of 2, we can just write here O of 3, O of 4, and so on. Like many other things, we can just have it in this particular manner. Okay, so these are the various time complexities, and it can go up till O of n. Okay, we can just have it as the O of n. We can just have that time complexity, the worst time case complexity, as O of n square. N is any particular number. Okay, it can go up till O of n square. N can be 10, n can be 20, n can be 50. It is just like a number. So these are the various worst case time complexities that we are having. So let's just understand, when do we write O of 1. Okay, firstly we'll understand when do we write O of 1, then we will move further. O of 1 is actually a constant time complexity. Okay, that means the program won't be affected, okay, by this time complexity. It will just take a particular unit of time. Let's say it is taking 1 second. Okay, so let's just take the unit time as 1, okay, as second. Unit time means you can be calculating the time complexity is millisecond, you can be calculating in a megasecond, nanosecond, according to your choice. So it will just take 1 unit of time, whatever you are talking about. Example of a constant time complexity is that what you are doing, you are just printing hello. Okay, you are printing hello. Now what is gonna happen? Hello will be printed only once. Okay, it will just take a unit of time. Okay, any particular unit of time that it generally takes to print a particular number. So that is a constant time complexity. Now then comes, what is the constant time complexity, or what is for next of time constant time complexity, that is O of 2. That means it is taking 2 units of time. Now what is 2 units of time? Let's say what we are having, let's say I'm just having particular loop that is a particular for loop, or let's say we are having two print statements. Easy, let's just keep it easy. I'm having two print statements, that is print hello, and again I'm having print hello, right? So what is gonna happen? It will take 1 unit of time, and again it will take 1 unit of time. So in total, we are having the time complexity as O of 2. Now, again, another question comes that why are we not talking about the exact time complexity? That is, why are we not talking about that this particular thing is taking, let's say, 10 milliseconds, this is taking 12 milliseconds? Why are we not talking about the time complexities in these particular exact time units? The reason is that each computer and each particular server, each particular value, each output will depend upon the computer itself. Okay, it is possible that if you are using an online compiler, it will take more time. It is possible if you are using a i7 processor, it will take less time. It is possible if your PC is running on Intel Pentium, it is taking more time. And if your particular compiler is outdated, it is taking more time. If your compiler is affected by some particular virus or anything, it can take more or less time. That is why we are just talking about a basic time, that is just an idea of time accordingly. That yeah, we can say yeah, this is equal to 1 unit and this is twice of it. We do not know that exactly twice. It can be 2.1, or it can be, for example, if I'm just taking an example, I can say A is having weight of 1 unit and B is having almost double of A. So we are not specifying anything, we are just taking an example of the time. So that is the O of n notation. So here we are taking two steps, that is why O of 2. So let's say if what if we were having n steps? Okay, n number of steps, n can be 15, 20, 30. So it would have been, the time complexity would have been O of n. So that is the basic time complexity that we have. So O of n time complexity can be achieved easily by just writing the loop int I is equal to 1, I is less than equal to n, I is plus plus, and then I am saying print hello. Now this hello statement will get printed n times because I is less than equal to n, and that is why the time complexity is n, because uh, each hello is taking 1 unit and we are just printing it n times, so it is having n units of time. Now, what happens when do we call the time complexity as O of n square, for example? Like I just wrote, when will it be O of n square? It is simple, when your particular loop will be working. For example, int I is equal to 1, I is less than equal to n, I plus plus, and again I am just writing a second for loop here, that is a nested for loop, and here I am just writing int j is equal to 1, j is less than equal to n, j value plus plus. Okay, and then we are just printing hello. So what is gonna happen? The outer for loop is gonna run for n times, and I'm just writing print hello. Now we know hello is taking 1 unit of time, and what is gonna happen? The outer for loop that we are having here, it will run n number of times, and even this will run n number of times. So n times this will run n times, this will run n times. So it is 2n times. Let's just take an example. Let's say n is equal to 10, and here n is equal to 10. So for each particular n, let's say for I is equal to 1, I am just writing the values here I, and the values of j here, and I am just writing the total here. Clear? So if I is equal to 1, j will go from 1 to 10. So the total number of values will be 10. Right? If I is 2, j will again go from 1 to 10. Right? So again the values is 10 and so on. And you can just notice I will go up till n, and at the end I is equal to n, j will be equal to 10 again, and what is n? I is equal to 10, and even here the value will be 10. So it is actually uh, n square. How n square? If n is equal to 10 and here we are having 10 values in total, so 10 plus 10 plus 10 plus 10, 10 times, so that will be 10 square. Okay, because 10 plus 10 plus 10, 10 times is equal to 10 square. So that is why we can just write it as 10 square and it will be 100, and even you will just add up 10 10 times, it will be 100. So that is how we just obtain the time complexity as O of n square. So generally whenever you will see a program that is having the nested for loop, you can just write it as n square. Now there comes a question, what if the external for loop, what if the external for loop is running n times? right? What if the external for loop is running n times, and what if the internal for loop is running let's say m times? Now what is gonna happen here? So you can just calculate that as well. It's really easy. What we are gonna do, just a second. What we are gonna do, we are again gonna make a basic table here, that for I is equal to 1, I is equal to 2, and so on. We can just write a line, and I is equal to n. Let's say n is equal to 10, right? I'm taking an example, n is equal to 10 and m is equal to, let's say, 5. So for each value, it will take 5 values here, and what will be the output? That will be O of n cross m. Clear? So it will go, this particular I will go up for 10 times, and this particular value will go up for 5 times. Okay, so it will be n cross m. So the particular time complexity will be O n cross m here. Clear? So that is how we just understand the time complexity easily. Now there comes a situation then when you will just see a time complexity that is written as O, and then we are having it as log n. Okay, so there comes a doubt that what is O of log n time complexity. So generally what are we having? O of log n time complexity. How are we having that time complexity? This particular time complexity is achieved when the number of steps are decreased, or when the array length, for example, whenever you will see array length is for reference, whenever the array length is decreased by half in each step, or that is when the length to be traversed is decreased by half in each step. So whenever you are having, and it will be having, just remember, it will be having the base 2 here, not base 10. There are two log values, log of base 2, log of base 10, and even log of base e. There are three types of logs. So here it will be log of base 2 n. So how do we just recognize it? It is the meaning is that what will be the power. Okay, like I'll just tell you the log explanation later on. So here what we are having, whenever we are having the length to be traversed is decreased by half in each step. Okay, that means what if we are having a binary search? Now what exactly is a binary search? I will just explain it to you. For example, we are having the values here. Okay, so what we are having six particular numbers in here, and I just want to find the number that is equal to 40. The target number is 40. So what will I do? I will just see that particular length of this value is 6, and what will I do? I will just do a 6 divided by 2, and it will be 3. Okay, so what will I do? I will just write for 3 elements onto this side, that is 10, 20, 30. So what we are doing, we are just dividing it into two parts. Okay, so this part is 1 and this part is 1. So what is going to happen here? This is the first part. This is the binary search that I am telling you, which will be having the time complexity of log n. Why log n? Because what we did, the binary search works in this particular manner, that firstly it divides the particular element into two parts. Now we will just see this particular center value. Central values, that is 0, 1 and 2. So we will just see that central value, that is the third particular value on the second index, because it is the third value. We will see whether this particular value is greater than 40 or not. For example, if it is less than 40, then we will just go on to this particular array. Then we will just divide it into two parts. Uh, it will be 40 and 50 in one part and 60 in the other part. So again we will just check this particular sub array, that what are the indexes here. Indexes are 3 and 4, and then we will just check whether let's say, for example, whether 40 is equal to 40 or not, and let's say our target element is equal to 50, for example, again. So I will just check whether 40 is less than or greater than 50. It is less than 50, then again I will divide it into two parts, and then we will have the answer. So what is happening here, rather than iterating over each element, what we are doing here, the length has been decreased to 3. Here the length has been decreased after, okay, this particular value, the length has been decreased into 2, for example, and approximately 1.5, and at the end the length has been decreased into 1. Okay, so that is exactly 3 divided by 2, that is equal to 1, because uh, talking about the integral differentiation. Okay, Now, this particular algorithm will have the time complexity of log n because the number of steps involved it is becoming half due to why it is becoming half, because what we are doing, we are just decreasing the length of the traversing. Okay, so let's just understand this a little bit more. Okay, let's just understand the binary search a little bit more and in more detail. Okay, so first question, whether log n is better or log or O of n is better. Okay, so I'm asking you a question that whether log n is better or O of n is better, which particular time complexity is less. So actually we want to compare these two time complexities. Now let's just understand it. Okay, for example, let's say I'm having a particular value, right? Any value I can have, let's say, okay, let me just give you an example for that. Okay, so let's say we are having again, but we are having 16 elements, right? So let me just write here 16 elements: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we are having 16 elements, and out of these 16 elements, let's say my target element that I want to find. Okay, I'm just telling you the binary search again and O of log n again. The target element is 9, for example. Okay, so the length of the array is 16, and what we will do, we will firstly select the middle element. And what is the calculation that what we are doing? I'll just tell you about the O of n and O of log n all together. So the length middle element will be 16 divided by 2, that will be equal to 8, right? 16 divided by 2, so 8 is the answer. Now what we will do, we will just select in the eighth element. What is the eighth element that we are having here? That is this particular element, right? So according to the eighth element, okay, what we are gonna do according to the eighth element, I'm gonna just divide it into the two particular halves. So what we are gonna do, we are gonna just divide it into two particular halves, and then we are gonna just check that whether the particular value 9 is greater than or less than to that particular value. For example, if it is greater than that particular value, then what we will do, we will just select this particular array, then we will just divide this particular array into the steps. So that is from 9, and this is 16 approximate. So 16 plus 9 is equal to 25. 25 divided by 2, that is approximately 12, and it will be this particular element, sorry, 12th element here. So what we are having, we are having this as the middle element. So this was our final array. Then we just divided this particular array into this particular part. Now we are having 9, 10, 11, and 12. Now we are having 4 elements, so 4 divided by 2 again. I will be having 9 and 10 here. Then I will be dividing it again into two parts. Then we will be having 9 and 10. And after that, at the end, we will be having the 9 found out. So that is the basic steps that we are having here. So what is happening actually, you can just see that I am just dividing the length 16. The 16 length that I was just having, what I am doing, I am just multiplying it by 1 divided by 2, right? I am just dividing this 16. So dividing 16 means 1 divided by 2. So how many times are we dividing? If I am dividing it one time, then we are having the length as 8. Then I am dividing it two times, then we are having length as 4. Then again three times I am having length this, and then this. So at the end you can just see, to just have these particular elements into one singular element so that the particular final value can be found, I just divided 16 four times. This is the first time, this is the second time, this is the third time, this is the fourth time. That means I can just uh, raise this particular value. I can just say 16 multiplied by 1 by 2 raised to the power k. And what will be the k here? K will be equal to 4, right? So this is a particular expression that we generally have, right? So what is n here? Let's just understand. Let me just write, convert it into the n particular format. So let's say we are having the n here. Okay, so it is n multiplied into multiplied divided by 1 divided by 2 raised to the power k. Okay, so this is the expression that we are having, and after doing this particular expression, what we get, we just get the final value as 1, okay, at the end. So what happens here, Now just imagine I am just multiplying the numerator and denominator. Okay, what I am doing, or I am just multiplying both sides by 2 raised to the power k. So what is going to happen? I am having this 2 raised to the power k here. So I am just multiplying both sides. To this is simple mathematics. 2 raised to the power k into n. Okay, divided by 2 raised to the power k here. This is the left hand side, and in the right hand side what we are gonna have, we are again gonna have 2 raised to the power k, right? So left hand side multiplied by 2 raised to power k, right hand side multiplied by 2 raised to power k. Here it will get cancelled, and the number of values that we are having, or the particular value of n, that is the number of elements in general, we know, now we know that the number of elements will be equal to, or will be solved in 2 raised to the power k steps. If I want to find a particular element by using binary search, then I will have to then the number of basic value, or the time complexity constant, that is n, is equal to 2 raised to the power k, because that is the number of steps or the divisions that we need to make. Now what if I will just take the log 2 on both sides? So if I will take log 2 on both sides, what will happen? It is the basic log statement, log 2, and here we will be having the n, and log 2, uh, and then the log 2, 2 raised to the power k. So 2 and 2 will get cancelled out in the log, because the base and constant cannot be same, and here we will have the number of steps as k. So we know that k was equal to 4, that was the number of steps here, right? And those k number of steps are performed in log base 2 n number of steps, or n number of log n particular time constant. Okay, log n unit time according to our calculation. Okay, so that is how the log n calculation, or the log n is calculated. So generally when we are doing a binary search, okay, or when we are just decreasing the array length divided by 2, we are just dividing it by 2 in each step, we can just calculate it that in that particular portion the value will go up till log n. Okay, so after that you can just see that we are having multiple data structures. Okay, in each data structure the time complexity will be different, and in each data structure, for example, if we are having an array list, now to insert a particular element into the array list, we will be having a particular code. Okay, for example, let's just open up a code that I already sent you. I will just open up any code that I just sent you. Wait a second. Okay, so let's just open up any particular code. Okay, let me just open up an array list code. Okay, for example, this one. So I'm just checking it from your WhatsApp chat itself, and the code that I have already given you is this one. Let me just write the code here itself. Okay, so this is the code that I already sent you. So what we are doing, we are just adding multiple objects into the array list. So how is the time complexity calculated here? So what we are having these particular values here. Let's just come to the main method. In the main method, we are declaring an empty array list. Then we are just creating the new object. So the new objects will be taking a constant time. So it can be O of 3 here. For example, it is just an example. So I'm just saying that yeah, we are having the O of 3 here. Then we are just adding up these elements. Again, we are having O of 3, and so on. So that is how these time complexities are being calculated, right? And let me just write in a particular program, okay, to just check whether a particular number is even or odd. Okay, so let's just start in with the basic program here, or yeah, let's just talk about the bubble sort. Yeah, bubble sort will be much better. So what will I do? I will just open the code for bubble sort, and I will just show you that. Hold on to that one. Okay, so I'll just show you some of the sorting codes itself that will just help you to just finding the time complexity. Okay, so this is the basic bubble sort code that we are having. Okay, so what are the number of steps that we are involving right now in this particular thing? Can anyone just look into this? Okay, just let me just zoom it in. Just a second, let me zoom it in. Okay, so the number of steps that we are having here, okay, the number of steps is that, okay, firstly we are declaring an array, then we are declaring a variable, and then we are running a loop, and how many times the loop is being run. Okay, so it is the last unsorted array, the last unsorted array is the last index. So actually we are just running it n number of times, and inside this particular value again I am just running this particular value into n number of times. So what exactly happens here in bubble sort, what we are having, it is a nested loop. So in general bubble sort is having the time complexity of O of n squared, right? You will also get a complete list of the various time complexities, okay, for each algorithm that you are having. So the first time case complexity of bubble sort is O of n square. That means the element that we wanted is in the last, or if you are just traversing from the last, the element that we wanted is in the first. So that is how the time complexities are calculated. So I will just send you the various basic charts that are having the time complexities of various algorithms and various sorting algorithms itself. Okay, so this was all. This was the complete time complexity and space complexity comparison, and I just told you almost everything about it. Okay, and the various things will be a little complex. The things get a little complex when we are not able to just find the time complexity of a long algorithm. Okay, so what happens, somebody can just show you an algorithm and he or she can ask you that what are the number of or what will be the time complexity. So for declaration of elements or for declaring things, we are having the time complexity of O of 1. For loop we are having O of n, the number of steps that you are having. Nested for loop O of n square. And if any particular for loop is having, let's say, if it is having a statement like this one, for int I is equal to 0, uh, I is less than equal to 10, okay, or int I is equal to 1, let's just do it in this way, and I is less than equal to 10. And here what I'm doing, I'm just writing, let's just do it in this particular, sorry, I'm just reversing the order. I is greater than equal to 0 and I is equal to I divided by 2. Now, in this particular manner, you won't say that it is log n, okay, because here we are having some number of steps. Here we are not changing the array length, okay. We are not changing or we are not dividing anything. We are just dividing the number of steps. Here it will just be O of 5, okay, because it will just take in 5 steps, 10 divided by 2, 10 divided by 2, 10 divided by 2, and so on. Let's just calculate not 5 exactly. 10 divided by 2 is, but in the first step 10 divided by 2 what we are having 5, then in the second step 5 divided by 2 what we are having 2, then in the third step what we are having 2 divided by 2, that is 1, and in the fourth step what we are having 1 divided by 2, and it will be 0. So in general what we are having, okay, what we are having, and first value of I will be 10, yeah, again. So what we are having 5 steps here, so I was correct. So here the time complexity is 5. It won't be log n because the array length was not being decreased. Now what if I am just decreasing the array length? For example, I am just saying that the array length will be equal to array length divided by 2, okay, and here we are having, let's say we are having any particular loop here, okay. So in this particular loop if I am decreasing the array length, then the time complexity will be O of log n. And if and here if we are again we are just adding n, or we are just doing some constant operations as well, the time complexity can go up till as O of log n. And what can happen, we can just say it was low O of log n, and plus it was O of, let's say, 5, some 5 constant steps were there. So the final time complexity can be written as O of log n, okay. It is dependent totally plus 5, okay. The statement is different here, the 5 is not attached with n. It is a different statement, and another one is a different statement. So that depends upon the algorithm to algorithm itself. So you can just practice 5 to 6 algorithms easily, and you can just like understand, like I just told you everything. You can just understand what are the time complexities, and we also know what are the space complexities. So this was your last lecture. If you are having any doubt, you can just like text me on WhatsApp. Okay, like even after 2 months, 3 months, or 1 year, I'll just get back to you. Okay. So thank you so much, guys.